Okay, here we go. The first assignment of a new unit. This is unit 5. And what we've learned in the previous unit is a bunch of things about derivatives, and we learned how to take derivatives of a lot of different equations. Now, what do derivatives help us with, and what do they tell us is kind of what we're going to kind of start transitioning to in unit 5 here. And so we begin by finding out and defining a few different things. Before we get to these problems, let's talk about a graph here real quick. Let's say my picture does something like this. Okay. Or let's make a couple of ways here. Let's go up and then really up and then something like that. There we go. And going up. Okay, so say this is our picture. Let's define a few different things. Let's talk about these tops. Okay, I'm going to ignore the endpoints here. I'm going to talk about the tops. And there are for sure points there. All right, and so these are going to be maxima. Okay, these are going to be maxima. And there's two different types. There's a relative, or AKA a local, and there is a absolute, AKA a global. So there's a such thing as a local or a relative maximum, and then there is also an absolute or a global maximum. And the little guys are relative. Like, so for instance, that is a relative maximum. Excuse me. The highest one of all of the maximums, if I take a look at the top dog of all of them, that would be the absolute. Okay. And the same with the minimums. And same with the minimums. There's a minimum there, minimum there. The lowest is the absolute. And then all the others are relative. And not to get into the finer detail of it, but just generally how you define a relative minimum, for instance, is if in this this little width that you have here, if it decreases and then increases from that, that makes it a relative min. Okay, it just locally around it, if it decreases to it and increases from it, it is a relative min. Okay, now talking about endpoints and things like that, is this. What if I had a picture that did this? Actually, let me make it a little bit easier here, just begin. Okay, so what is the highest point that we have here? Well, that's the highest point that we have right here. And because it's actually a point, that's the absolute max. There is no relative maximums here. And then this would be the absolute min. Now, if, say, for instance, this is an open dot where it goes to it, but there is no actual highest point, then that is not, it's not It's just, it's not a relative maximum, it's not an absolute maximum, it doesn't exist there. You have to have something. So this has an absolute minimum, and that's it. And that's it. So there has to be a for sure point for the relative max or min to exist. So what do you say in a situation that has this? Okay, identify all the relative and absolute maxes and mins. All right, so important pieces are obviously the endpoints and all the tops and bottoms in between. All right, so this right here is nothing. It's not a point. Nothing exists there. Nothing. Okay, so question, this is obviously a maximum, but is that a relative maximum or is that an absolute maximum? And the idea behind this one is this is relative, because there is more graph that is physically above this. There is actual concrete points that are above that point. So there are more points, so it is not the maximum of all maximums, but it is a relative maximum. Okay, what about this guy down here? This is obviously a minimum, but is that an absolute minimum? Yes, it is. Because there is no graph, there is nothing lower than that minimum. That is the absolute minimum. Okay, that'll kind of get us down the road here. That'll get us started. All right. Now, we begin today's lesson by identifying derivatives. And notice that in all of these derivatives, 1, 3, and 5, they're picking out, in essence, a minimum at these things. And so what we're going to see is all of these derivatives of these at that minimum point will either be 0 or undefined. It'll be one of the two, and that's what they're trying to show us here. So let's take the derivative at this point. So the derivative is bottoms up. Derivative of the top minus, leave the top alone, derivative of the bottom, all over the bottom, squared. Okay, so we have the, oh, sorry, right here, so, jeepers creepers, losing control of the whole world. Let's fix this right in here, right now. Okay, so we have this derivative. Very good. Now we are going to investigate this derivative at that minimum point. So notice what the x-coordinate is at that point. The x-coordinate is 0. So we are going to check this derivative when x is equal to 0. So the numerator is 8x, so that is 0. The denominator is 0 squared, so that's 0 plus 4, so that's going to be 16. Ultimately equal to 0. Vertically here, equal to 0. And that's what we're going to see. As I said, at these minimums and maximums and all these extremas, the derivative will either be 0 or undefined. And that's the definition of what we're going to define as a critical point. All right. Before I get going with the derivative, let's just rewrite this. This is x plus 4x to the negative 2. All right, so the derivative will be 1 minus 8x to the negative 3, or in other words, 1 minus 8x to the third. Derivative. We notice that the minimum point is at 2, 3. So we are going to be checking this derivative when x is equal to 2. So that's 1 minus 8, 2 to the third. 2 to the third is 8, so this is 1 minus 1, and thus that is 0. You know. And then last but not least, these first one is number 5. So we jump into the derivative. So this is 2/3 x plus 2 to the negative 1/3 times 1 with the chain rule. And then it'd be 3/3 root x plus 2 all underneath 2. All right, so that's our derivative. And we are taking this at an x coordinate of negative 2. And we're going to see what happens here. So that is 3/3 root of negative 2 plus 2, all underneath 2. So this this root is 0. And so that's a denominator of 0, thus that is undefined. All right, so at all of these minimums, we notice that our derivative is equal to 0. And that's going to pretty much be the definition of what we're going to define as a critical number. Okay, so here we go, approximating critical numbers. Critical numbers. Again, definition of what a critical number is I'll put it with this page here, is a critical number. Critical number is where the derivative is either equal to 0 or it's undefined. Right, those are critical numbers. And what critical numbers often define for you is potential maximums and minimums. So where derivatives are equal to 0, or if it's undefined, something like this. Okay, so this will be undefined right here. But it will tell you, it's not saying that it's absolutely for sure a min or a max, but it's an important number that you should at least consider. And then we're going to ultimately learn the criterion test, which is we take a look at all critical numbers, and then we also take a look at the endpoints and we compare all of those numbers. And that will tell us relative mins and maxes as well as absolute mins and maxes. Okay, we'll get to there. So right now we're going to be approximating, so we're just kind of right there-ish. And so that is at the 0.24, and we have to define what the heck is that. And so I see that it's a maximum. There is no other maximums higher than that. That is an absolute maximum. Okay, critical numbers are where derivatives are equal to 0 or undefined, right there. So we have 3 points. We have the 0.13, we have the 0.20, and we also have the 0.33. All right, let's go with 1,3. Yes, it is a top of, so it's a maximum, but is it a relative max or an absolute max? And notice how those two are at the exact same level. In that case, they're both absolute. It's weird to have multiple absolutes, but this is a situation where you have an absolute dual absolutes when they're higher than anything else. And then similarly with that one in the middle, it's an absolute minimum. Okay, next we're asked to find critical numbers. Again, critical numbers are where derivatives are equal to 0 or undefined. So we start with the derivative. All right, where the heck is this equal to 0? And so I can take out a 2, so this is what, 4x minus 3. Thus, this is going to be positive 3/4. All right. 13, I'm going to rewrite it. So derivative of the t is 1 plus, leave it alone, derivative of the second is 1/2. A little bit more room, and then I'll shrink it down here. Just get a little bit more room. 1/2 of 4 minus t to the negative 1/2 times negative 1 on the chain rule. So this is going to be 4 minus t to the 1/2 minus t to 4 minus t to the 1/2. So common denominator sort of idea. This side needs a 2 and a 4 minus t to the 1/2. So notice how the 4 minus t to the 1/2 will turn out to a normal 4 minus t, but it also gets distributed with this 2 that is on the outside. So doing the multiple steps at once, this is going to be 2 multiplied by the regular, so that's 8 minus 2t minus t all over 2 4 minus t to the 1/2. One more time, this is going to be negative 3t plus 8 over 2 4 minus t as such. Okay, so we have our derivative. Okay, so what we're after is critical numbers. It's like, where is this 0 and where is this 0 or where is this undefined? So 0 would imply where is 3t plus 8 equal to 0? And so that would obviously be at what, 8/3? Okay. And then the undefined where would be where 4 minus t is less than or equal to 0. That's where it'd be undefined. And that would be where t is greater than or equal to 4. But the original condition says t is absolutely all the time less than 3. So this doesn't make any sense. And thus your only critical piece would be this 8/3. Okay. Again, I'll rewrite this once. This is sine squared. Okay, so derivative is the 2 sine x to the first power. Chain rule is still on the sine, so that goes to cosine. Okay, plus derivative of cosine is negative sine. All right, so this is the derivative. We want to know where is this thing equal to 0. So this would imply, I'll make it easier on ourselves. I'll GCF out of sine x. So that leaves 2 cosine minus 1. Okay. So again, I'm taking a look, where the heck is this derivative equal to 0? And so here comes the unit circle. Okay, the first one is the sine. Where the heck is sine equal to 0? Sine is the y coordinate. So these are the places where sine would be equal to 0. So that would be something like 0 and pi and 2 pi and things like that are the places where sine is equal to 0. Take a look at the guide, and it specifically says that x can only be between 0 and 2 pi and not actually 0 and 2 pi. So we get a critical number of pi. All right, here we need this cosine to be a positive, 1/2? We need cosine to be a positive 1/2. All right, so take a look at where the heck is cosine 1/2. And cosine, again, is the x. 1/2 is small, so it puts me at those locations, which is what, pi over 3, 2, 3, 4, 5, pi over 3 as well. And so the final result is pi over 3 and 5 pi over 3. And last but not least is this number 17. So we take the derivative. So the first part is the t, so that's goes to 1, so that's e to the negative 2t plus, leave the t alone, derivative of the e portion. So e is e, and then the chain rule is a negative 2. So again, I will GCF out from e to the negative t, so that'd be 1 minus 2t. So I need these portions to be equal to 0. Well, the problem with that is this in e, okay, what this tentatively looks like is something like that. But notice how it is never equal to 0. It is never equal to 0. So this outside is never going to be equal to 0. So you're not going to get a critical number coming from there. However, this inside t is another story. And that would be what? Positive 1/2. Positive 1/2 would be your critical number on that. All right. All right, so here we go. Moving on. We are moving on to 21, and now we're going to be, in essence, finding the extrema. So we're going to be finding absolute maxes and mins, and we are going to do what is known as the candidates test. Okay, so the candidates test is this: is you find all critical numbers. Okay, and so we take all critical numbers as well as endpoints. So, all critical numbers and endpoints. And so let's say we did that, and let's say we are on an interval that is, like -1 to 2 or something like that. And we found some critical numbers that are on that. So when we find our critical numbers, what we do is we plug all of the critical numbers. Let's say we had a critical number at 0. Let's say we had a critical number at 1/2. And then we obviously have to use as well too. So what I'm saying is you test all critical numbers as well as the endpoints. And what's going to happen is you put it back into the original function, not the derivative, but the original function, and you get various answers. Like I could get the answer of 2 and -1 and 1 and 0. Let's say I get these answers. All right, what do those answers say? Okay, so what we've done is we've identified all the potentially important pieces. And so what I notice is with this, at this -1, 2 is the biggest y coordinate. This would be your absolute max. And that would occur at -1, 2. At the exact point of -1, 2 would be your absolute max. See if you can identify the absolute minimum. And that obviously would be the smallest answer. And that would occur right here. This would be your absolute minimum. And that would occur at 0, -1. And then all these other pieces in between are, potentially relative minimums and maximums and things like that. We're not quite sure, but they're definitely not the absolute mins and maxes. Okay, so this is called the candidates test. So we get all these different candidates, and then we test all the candidates. All right, so that's what we are going to be doing with these problems down here. Is we're going to be doing the candidates test and be able to identify any absolute maxes and mins. Okay, so the first thing that we need to do is we need to get our candidates, which is derivatives equal to 0 and stuff. And so f prime of x is equal to -1. So that is never going to be equal to 0. So you're not getting any critical numbers in the meantime. Okay, you're not getting any critical numbers in the meantime. All right, so but we can still do the candidates test. We don't have any critical numbers, but we still have to test the endpoints. Now I'll kind of teach you a trick on your calculator here. Let me go to my computer so you can see my cursor. A lot of times I'm not really worried about you doing math correctly. I just need you to get the answer and understand how to use the answer. So for instance, let's pretend like this was more of a complicated equation and I needed to use -1 in this complicated equation. What I do a lot of times is I store that letter literally as the letter x. How I do that is this. Okay, I'm going to be making -1 my x. So I go -1, and then I use this STO, the STO button. I store that number, and then I come up here to that xt theta n, and that comes out as the letter x. And so what I'm doing is I'm taking -1, and it's stored in my calculator as the letter x. So now when I use the letter x in my regular calculator screen, not the graphing, but the regular calculator screen, the calculator recognizes that x as being -1. So if I go, for instance, 3x, that's 3 times -1, and thus it's -3. Now all I have to do is just type in the problem that I have, and it will spit out the answer. Because again, I'm not really worried about the algebra and you doing the algebra correct. So here I'm going to do that with 2. So I go 2, store x, and now again I can type it into my problem. Okay, so we get these answers coming off of here. And so let's interpret what these mean. So the biggest number, 4, that's going to be my absolute max. And that occurs at -1, 4. That's the x and y coordinate. And my absolute min is going to occur at 2, 1. So the candidates test is used when specifically trying to find the absolute maxes and mins. All right, number 23, same idea. Let's find the derivative. So h prime of x is -4x. So I see that there is a critical number when x is equal to 0. So my candidates test would be testing out -3, 0, and 1. And again, we go back to the original. suffix. That should have been the letter H. We go back to the original H, not the derivative, the rigid. So here we go, -3. I'm going to store that as x, and this is 5 minus 2x squared. So that is -13. 0. Comes out as 5. And then 1. Comes out as 3. So interpreting these results, the biggest number is 5, so the absolute max is at 0.5, and the absolute min is at -3, -13. Okay. The same concept rolls on. I'll teach you one more trick here as well. So first problem that I'm going to be using is -1. So I go -1, store x. I type in my formula, so that's x to the third minus 3 over 2x squared. I get my answer, go math, enter, enter, -5 over 2. So so I did a couple of different things there. So when I got this number, so again, it was x to the third minus 3 over 2 x squared. Okay, getting me this decimal answer. What I do is I hit math and then enter, enter, and that gives it to me, if possible, as a fraction, -5 over 2. All right. So now I'm going to be using this number 0. So 0, store x, and then here's where you would type it back in. But this formula is kind of long, and like, why do I have to retype it? Well, if you hit second enter, which is in essence the entry, what it will do is it will bring back in previous things that you typed. So second enter, second enter. One more, second enter. Ha, there it is. It brings back into the equation that I was looking for. And now, ta-da, I can get that without retyping the entire thing. So again, I'll show you how to do this one more time. So enter your new variable. This is going to be 1, so 1 store x. And then I go second enter, and that's the formula that I wanted. And hit enter, and that's what, -1/2. Math, enter, enter, -1/2. And then you can kind of continue this process to store x, second enter, second enter, second enter, and that is 2. So what do I notice as my maximum? That's the 2. So my absolute max is at 2, 2. And my minimum is at -5 over 2. So my absolute min is at -1, -5 over 2. Give fractional answers, not decimal answers. It makes it look like you actually did the math as opposed to using your calculator. So give fraction answers whenever you can. All right, derivative time, I'll turn it to that, is 2/3, so that's 2x to the -1/3 minus 2. So this is 2 3rd root of x minus 2. All right, so right now, what can x not be a critical number is instantaneously 0. So we'll put that kind of in our back pocket here, and then we're going to see, actually, that's the only critical number that would come off of this. It's not, I guess you can make this a -1. Yeah, x is also -1. So again, math. Or excuse me, +1. So that would mean 2 third root of x is equal to 2. 2 is equal to 2 third root of x. 1 is equal to third root of x. X is equal to 1. Okay, so another critical number at 1. I'll just kind of cut back. So critical numbers coming off of this, again, x can't be equal to 0, so that's critical number, as well as if it's 1, that would make this derivative equal to 0. Okay, so there are two no-nos there. So either undefined, okay, undefined, or equal to 0. You get both of them there. All right, so candidates test would be at -1, 0, and 1. It's both a critical number and an endpoint. So 0, this is 3x to the 2/3 minus 2x. 0, 0 is 0. 1 is 1. You agree? This -1, just -1 is 1, 3. -2 is 1. No. I'm just thinking here, I'm just doing mental math. I just need to step it through just once. So 3 third root of -1 squared minus 2 times -1. So -1 squared is 1, 3 times 1 is 1, plus 2 should be 5. -1 store x. I'm going to just try this one more time. It's 5, yeah. Okay. I don't know if it just, I was working too fast or something, but yeah, 5. All right. 0 is 0. That's no change. And then 1 is 1. So yeah, 1 is 1. Okay, yeah. So for some reason, the -1 was coming up with a crazy number. I probably had a button slip somewhere. All right, so absolute max is at -1, 5. And absolute min is at 0, 0. All right, so this h of s is s minus 2 to the -1. So the derivative is going to be -1 s minus 2 to the -2 times 1. So this is s minus 2 squared underneath -1. So it's never going to be equal to 0. However, it can't be +2. So you're getting a critical number of +2. It's not going to make the derivative equal to 0, but that it is a critical number and make it undefined. However, notice how that does not come in the range of our interval. Doesn't play into our interval. So even though it would be a critical number if our interval was wider, but we're not looking at anything beyond 0 to 1. So our entire candidates test is just at the two endpoints because the 2 doesn't fit in there. All right, so 0 is -1/2, 1 is -1, and so our absolute max is going to be at the 0, -1/2, and our absolute min is going to be at 1, -1. Kind of tricky there. Sorry. All right, 37, f prime is the cosine, so that's negative sine. And where is this equal to 0? Well, that implies where sine of x is equal to 0. Where the heck is sine of x? Sine is the y-coordinate. And so it'd be 0 at 0, pi, and 2 pi. 0 pi and 2 pi is where sine is equal to 0. And so those are our candidates as well as our endpoints. So they're both. So this would be f of 0, f of pi, and f of 2 pi. And so cosine at those things, cosine is the x-coordinate, and so that would be this is at what? 1, 0. This is at -1, 0. And so when it's at 0, that would be cosine is 1, that'd be 3. When it's at pi, it's -1, that'd be -3. When it's at 2 pi, again, it's 1, and that'd be 3. So it shows that my absolute maxes occur at 0, 3, and 2 pi 3. And then my absolute min occurs at pi -3. Okay, let's see what is true about that. X has a minimum at -1, -5. No, there's not even a point there. So notice how it's an open dot. So nothing exists there. Nope. It does not have a minimum. Has an absolute minimum at 4, 0. Even though there is a dot, but notice that there is more stuff below it. So it is not an absolute. It is not an absolute. No. X has a maximum at 2, 4. Yes, it does have a maximum. Let's see if we can get more specific. H has no, it does have an extremum at 2, 4. The critical numbers of blah, blah, blah are, so that would be the derivative. So here comes the derivative. First is the x squared, so that's 2x. Leave the second piece alone. Now leave the first piece alone, derivative of the second, which is 3, 3x minus 1 to the 2 times 3 on the chain rule. So this is 2x, 3x minus 1 to the third, plus 9x squared, 3x minus 1 squared. All right, I think I know the trick to this one. So what can we GCF out? We can GCF out an x and a 3x minus 1 squared. And that would leave us a 2, 3x minus 1 plus 9. I think that's the trick. I don't think I did any illegal math there. I might have. I don't know. We'll figure it out. So critical numbers are 0, positive 1, excuse me, as you were, positive 1/3, and this is what, 6x minus 2 plus 9, so this is 6x plus 7. No, I only took out one x. Make this one wrong. So x, which leaves us, I'm sorry, 2. I have to just back up. If I GCF'd out that, I didn't quite get it quite correct. 2, 3x minus 1, and then a 9x. There it is, 9x is that piece. Okay, sorry. And so again, what I'm looking for is where is this equal to 0? So I have a 0, a positive 1/3, and this bit is 6x minus 2 plus 9x. And so that's going to be 15x minus 2. And then if that's equal to 0, this is positive 2/15. So all three of those things.